Right. So let's take a look at ISI 2026 PEB question number 7. A household lives for 2 periods. So period 1 है, period 2 है. In each period, it chooses a consumption CT, to C1 and CT. Labor supply is NT, N1 and N2. Savings जितना कर रहा है, it is getting S into 1 plus R in the next period. Household earns wage income this, plus there is a government transfer. So W2 N2 plus government transfer. Okay. This N is basically the labor. Okay. And let's take LT as nothing but 1 minus NT. It will be easier for us to solve in that way. Okay. This is basically the leisure. So the utility is dependent on how much of leisure am I able to take rather than the labor. That's why it's 1 minus the labor that I'm putting in. This is the leisure. The household faces budget constraints C1 plus S is equal to W1 N1 plus T1 and C2 is equal to 1 plus R into S plus W2 N2 plus T2. ठीक है, ये दिया हुआ है. This is basically standard. Consumption in the second period is whatever I save in the first period plus whatever I get in the second period. And consumption in the first period plus the saving is whatever I earn in the first period. That is but obvious. Government satisfies present value transfer constraint. That is T bar is equal to T1 plus T2 by 1 plus R. Okay, so the transfer is constant in this way. T bar is equal to T1 plus T2 by 1 plus R. Part A is solve for the household optimal consumption allocation C1 and C2. ठीक है, ये सारा इंफॉर्मेशन है. लेट्स गो ऑन टू द बोर्ड. चलो एक साथ में इसको सॉल्व करते हैं. सो लेट्स अंडरस्टैंड व्हाट इज हैपनिंग हियर. In each period, the household has an implicit time endowment. So time, अगर मैं पकड़ के चलूं, time endowment is equal to 1. Therefore, I am being able to write LT is equal to 1 minus NT. Basically, the amount of leisure is the time endowment minus the labor that I'm putting in. Or in other words, NT is 1 minus LT. ठीक है. सो अब बजट कॉन्स्ट्रेंट को देखते हैं. बजट कॉन्स्ट्रेंट कैसे चेंज करता है. C1 प्लस एस इज इक्वल टू W1 N1 था, वो 1 माइनस L1 लिख देंगे प्लस T1, which basically means C1 plus W1 L1 plus S is equal to W1 plus T1. ठीक है. C1 plus W1 L1. So what is happening? I'm trying to write it down in C1 and L1. Okay. Clear? And second is C2 is equal to 1 plus R into S plus W2 into 1 minus L2 plus T2, which basically gives us C2 plus W2 L2, taking it on the other side, is equal to 1 plus R into S plus W2 plus T2. Now consolidating these two constraints and isolating S. So basically S nikal gaya from the first one. S is what? S is W1 plus T1 minus C1 minus W1 L1. ये अगर मैं डाल दूं इसमें C2 plus W2 L2 plus sorry is equal to 1 plus R into S is W1 plus T1 minus C1 minus W1 L1 plus W2 plus T2. So I basically try to consolidate this. C1 plus W1 L1 I basically divide by 1 plus R throughout, plus C2 plus W2 L2 by 1 plus R is equal to W1 plus T1 plus W2 plus T2 by 1 plus R. Am I making sense? This is my consolidated lifetime budget constraint. So I'll call this full lifetime budget constraint. Okay. Okay. Now it is given to us that T bar is equal to T1 plus T2 by 1 plus R. So this is nothing but W1 plus W2 by 1 plus R plus T bar. Can I write it? And this lifetime, this is my income sorts. This I can write as omega. This I call as full lifetime wealth. Therefore, consolidated budget constraint is nothing but C1 plus W1 L1 plus C2 by 1 plus R plus W2 L2 by 1 plus R is equal to omega. Am I clear? ठीक है? This is what we have. This is basically setting up the problem. अभी तक तो problem setup किया है. Now we'll get into solving. चलो अब part A में चलते हैं. Part A is solve for the household optimal consumption allocation. हमें C1 and C2 का values निकालना है. अब why did I do this? It will make things very easy. L1 C1 plus L1 L1 ln L1 plus beta ln C2 plus beta ln L2. This is what my utility function is, right? Basically 1 minus N1 tha, which I'm writing as L1. Subject to the constraint C1 plus W1 L1 plus C2 by 1 plus R plus W2 L2 by 1 plus R is equal to omega. Now, please notice that this is a standard Cobb-Douglas. If you take a look at the utility by monotonic transformation, I'll get C1, L1, C2 to the power beta, L2 to the power beta. Now, if I add the powers, it's basically 2 plus 2 beta. Okay. Standard Cobb-Douglas. Now, I'm going to use the shortcut. अभी तक तो शॉर्टकट तो आप लोग सब कोई को पता होना चाहिए, राइट? ओके, सो लेट्स गेट इनटू द solving. So C1 star will be basically the power of C1 divided by the summation of all the powers into omega. C2 is nothing but C2 का power divided by summation of entire power multiplied by omega divided by 1 by 1 plus R. So basically 1 by 1 plus R. Basically it will be beta into 1 plus R. So this will be beta into 1 plus R divided by 2 into 1 plus beta into omega. Therefore, final allocation I just have to put in the value of omega. C1 star is equal to W1 plus W2 by 1 plus R plus T bar divided by 2 into 1 plus beta. C2 star is therefore equal to W1 plus W2 by 1 plus R plus T bar whole multiplied by beta into 1 plus R divided by 2 into 1 plus beta. ठीक है, this is part A. ठीक है, now this is my C1 and C2. अब part B क्या है? Does optimal consumption depend on the timing of transfer T1 T2 or only on their present value? हमने देखा it is depending only on the present value. Okay, so what is the reason for that? We'll have to tell. Correct. So B का आंसर क्या है? Optimal consumption depends only on present value T bar, not on the timing of the transfer T1 and T2. So the optimal consumption formulas C1 star and C2 star depend on consolidated full-time wealth parameter omega, because capital market is perfect. The household, what does that mean? The household can borrow or lend at same interest rate R. Okay. Any change in timing of transfer, any change in the timing of transfer T1 and T2 that holds T bar constant leaves my omega unchanged. So any T1 and T2 fluctuations or variation, T bar to constant hai. So my lifetime budget or my lifetime income, which is omega, is unchanged. If my lifetime income is unchanged, it is not going to have any effect on my consumptions. Okay. For your information, this is a classic demonstration of Ricardian equivalence. If government shifts transfers from period 1 to period 2, household perfectly offsets this by adjusting private savings. So the tool that the consumer has in their own pocket is the savings, offsets this by adjusting their private savings by exactly same amount, leaving real consumption allocations entirely unaffected. Clear? All right. So this is my part B. अब पार्ट सी में चलते हैं. Part C is interesting. Now, suppose the household evaluates period 2 utility with an additional present bias delta. तो पहले खाली बीटा था, अभी एक डेल्टा इंटू बीटा आ गया. बीटा आई ऑलरेडी नो इज बिटवीन 0 to 1 and delta is also lying between 0 to 1. The household cannot commit. In period 1 it is choosing C1N1S, and in period 2 it is choosing C2N2, taking savings as given. So we'll have to do backwards in this case. I will take savings as given for period 2 and then solve it, and then substitute that into the period 1 and then solve. Okay, solve for the optimal consumption allocations C1 and C2. ठीक है, savings is given. तो अब ये वाले सिचुएशन में क्या करेंगे? So part C. So U1 is basically L1C1 plus L1L1 plus delta into beta lnC2 plus lnL2. Because the household cannot commit, this is because it's given in the problem, because household cannot commit, I will choose the self 1 in period 1 and self 2 in period 2. ये self 2 क्या कर रहा है? Self 2 is choosing only C2 and L2. Self 1 is choosing C1, L1 and S. Okay. So what do we do first? We solve for C2, L2 given S. Okay. So we'll solve this first. So then what am I supposed to do? Step 1. I'll solve self 2 problem first. I need to basically solve this subject to C2 plus W2L2 is equal to 1 plus R into S plus W2 plus T2. Okay. This I call it supposing omega 2 as a function of S, because S is given here. S आपको दिया हुआ है. S is a constant here. Okay, again, this is a standard Cobb-Douglas optimization. This can be written as C2 into L2, monotonic transformation of a Cobb-Douglas. So here, basically, C2 will be basically 1 divided by the summation of the two powers multiplied by omega 2 divided by the coefficient, that's 1. So it's basically omega 2 by 2. And L2 is basically 1 by 2 into omega 2 divided by the coefficient, that's W2. Okay. Now, this is my C2 and L2. Now, self 1 will anticipate this. So step 2 is basically now going to first step. So basically, what will happen is now we shall solve for period 1. Okay. We will substitute C2 and L2 as a function of S into utility function of consumer. So U1 is basically L1, ln C1 plus ln L1 plus delta beta ln C2, which is basically omega 2 by 2 plus ln L2, which is omega 2 by 2W2. Clear? So the utility can be basically written as ln C1 plus ln L1 plus ln omega 2s plus ln omega 2s minus something something. So I can write 2 delta beta ln omega 2s plus some constant. This constant is nothing but delta beta minus ln2 minus ln2 W2. Okay. Now, from period 1 constraint, we know savings is equal to W1 plus T1 minus C1 minus W1 L1. Let us substitute this here. Let us substitute this here. So I have to basically maximize the utility function subject to the budget constraint. I'm getting the budget constraint into the utility function itself. So then I can basically just maximize the utility function itself and I'll get the answer from there. Okay. So till this, is it okay? Chalo, theek hai. Now let's substitute. Omega 2 is nothing but 1 plus R W1 plus T1 minus C1 minus W1 L1 plus W2 plus T2. Basically 1 plus R into S था ना, S की जगह में I've basically put this. Okay. So this is equal to 1 plus R into W1 plus T1 plus W2 plus T2 by 1 plus R. I'm writing it down in that way. Okay. Minus 1 plus R C1 minus 1 plus R into W1 L1. ठीक है, written it in that way. इसको ऐसे क्यों लिखा? Because this is basically giving me the omega. So 1 plus R omega minus C1 minus W1 L1. This is my omega 2. So U1 is ln C1 plus ln L1 plus 2 delta beta ln omega minus C1 minus W1 L1 plus some constant. That constant I have already shared. So I will basically maximize this with respect to C1 and L1. FOC conditions. U1 del C1 1 by C1. This will be basically minus 2 delta beta by this minus C1 minus W1 L1 is equal to 0. Or in other words, omega minus C1 minus W1 L1 is equal to 2 delta beta C1. Del U del L1, 1 by L1 minus 2 delta beta derivative 2 delta beta minus C1 minus W1 L1 into W1. Okay. Or in other words, omega minus C1 minus W1 L1, just take it on the other side. This is equal to 0 basically. Take it on the other side, go there. This is equal to 2 delta beta W1 L1. So basically these two are the same. So I equate this. What will I get? Because this is the same, I'll get 2 delta beta C1 is equal to 2 delta beta W1 L1. So ultimately I'll get C1 is equal to W1 L1. Okay. Now substitute it back in one of the equation. If I substitute W1 L1 is equal to C1 here, I can easily get, what will I get? Omega minus C1 is equal to 2 delta beta C1. So this will go there and I will get C1 is equal to omega divided by 2 1 plus delta beta. Am I clear? This 2C1 goes there. C1 takes 2C1 takes common 2C1 into 1 plus delta beta. That is what I'll get. So I'll just take that on the other side. That is my C1 star. Clear? Now, to find C2 star, we must first evaluate residual wealth omega 2. Okay. Omega 2 star. Basically, I need to find out S star. 1 plus R omega minus C1 star minus W1 L1 star is equal to 1 plus R into omega minus 2C1 star, because W1 L1 is equal to C1. Omega 2 is 1 plus R minus omega by 2 into 1 plus, so 2 into 1 plus into 2, because both are the same, because this is 2. Okay. So that is equal to 1 plus R into delta beta by 1 plus delta beta omega. C2 star was equal to 1 by 2 omega 2 S star. So 1 by 2 into 1 plus R delta beta divided by 1 plus delta beta into this. Therefore, final allocation C1 star is W1 plus W2 by 1 plus R plus T bar whole divided by 2 into 1 plus delta beta. And C2 star is also equal to um, complicated delta beta 1 plus R, delta beta 1 plus R, omega is W1 plus W2 by 1 plus R plus T bar whole divided by 2 into 1 plus delta beta. Okay. So basically what we are getting, because delta is less than 1, effective discount factor drops to delta beta. Household over consumes, therefore in period 1, because वो discount कर रहा है, second period consumption is not as valuable as it was earlier because delta is a fraction. Household over consumes in period 1, that is what happens is C1 increases and he saves less compared to full commitment benchmark in part A. ठीक है? That is what happens here. Am I clear? So that is this question number 7. Done.